What's going on, everyone? Sorry for not posting for so long time a big video. I was working on this thing and this took a long time to print. If you're printing it all at once, probably will take you maybe a week to print this one, maybe a little bit less. It depends on your printer and your settings. For me, it took me almost a month to print just because I was printing other things in between. If you read the title already, you know already what it is. Spray paint can shaker. Not necessarily you can use whatever you're gonna fit in this circle, you can use and shake whatever paint you want. I've seen people do something like that already, but not for such a large cans. I've seen people do for like a Tamiya model paint, but that doesn't work for me, so I went to Fusion and I designed my own. The biggest part to print was this thing. This took almost 2 days to print. The reason is I overdo with the settings. I make almost 2.8mm walls, or 2mm, or 2.4 or 2mm top and bottom layer, something that this thing I don't believe that it needs, because seeing it now printed in that kind of settings with 2.8mm walls and 2.2, let's say, top and bottom layers, I think this is pretty sturdy and it's an overkill, let's say like that. So if you're printing this one, I would suggest maybe 1.8 walls or 2mm walls and maybe like 1.6 top and bottom layer, maybe, but that's all up to you. The biggest issue you're probably gonna have here when you're gonna start tightening, so this will not break, I suggest this one doing it until or 100% infill, or at least 2mm walls and 2mm top and bottom layers. This will be a 10 file print, but you're gonna need some hardware. You're gonna need 10mm bolt with a height of 137mm. You're gonna use 2 bearings. I have some kind of wheel bearings I just had around, so I'm gonna use them. But as long as you have a bearing that measures 22mm, and of course it has to fit the bolt, so it will be, the inside circle will be 10. You're gonna need a smaller bearings. This bearings measures at 8mm. You're gonna need bolts that are 3.8, let's say 4mm bolts. You're gonna need electric motor that measures 27.5 with a height, I mean the height doesn't matter much, with a height of 38. You're gonna need some threaded inserts, and 5 times 9.5. You're gonna need some bolts for the threaded inserts, 5 by 10, and you're gonna need a switch and a power supply. If this will fail or if this will not work, it will be because of the electric motor. This electric motor, I think it's if I'm mistaken, a 12 volt, 9 or 10 or 12 volt. It's from an electric vacuum cleaner. I don't have much hopes that this will move this one, because this is pretty heavy, but in case this will not, I will redesign this thing. The clever way I did with this one is I have holes here to do threaded inserts, so I can just add a plate that has a gears or something. Let's assemble something. Let's add the threaded inserts first. This thing gets threaded inserts too, and the reason for this one is for the bearings to have something, you know, instead of plastic, but the metal to ride on. So let's assemble this. So you get this piece, flip this thing around, slide it like that, the holes line up. Of course they do, I design it. What do you think? So let's add our electric motor, and of course you have here 2 holes to hold the engine in place by the original mount. Look at it, how good it fits. Fits like a glove. You'll get your cover. This slot here is to hide all the cables. We need to put our bearings inside of here. The easiest way to put the bearings will be to just drive them through with the bolt. Put your bearing here and here, and then just tighten the nut so they will go to their places, or put them in the freezer. You can see the bearing here, supposed to be sticking a little bit out so it can sit on the lip layer, and this one's supposed to be flush. Add some grease. Inside here there is a notch for a nut. So we're just gonna thread it and then put it in. This thing here is designed in a way that you can put a socket and measure a socket. Are you surprised as me that the small electric motor did not work and I had to improvise? So yeah, the small electric motor did not work. You can try something bigger, but still they don't have enough power to move this one. Especially this is like I said, like this is like 600-700 grams maybe worth of filament of plastic. Even with bearings, very difficult for it to move, and I knew that one, but I always had a plan B to use this thing. This thing is from a Power Wheels. This is like a gearbox with the same motor but with a gearbox. So I redesigned this part here. I made it. This was the original part, but of course it will not fit. It will fit. It will make the hole bigger, but it will not spin. So I designed a different coupler here, different adapter, and the way. So in the files, I'm gonna include this base, but this base will not have the other piece sticking that you're gonna put your motor in. It will be flat. It depends what they like. I don't think so they're all the same. Those are very cheap. I think you can find them for Amazon and eBay for 7 to 10 euros. I will not include holes because like I said, every electric gearbox will have a different mounting points. So you'll have to measure it, drill your holes, put your threaded insert, and mine is sticking a little bit up just because there's a gap that the electric motor is sitting. You'll have to modify the case as I did here, that I cut this piece and I cut this piece here. So you may need to modify a little bit the case, but as long as you can place it in the right position, everything else goes as planned. You will have to find your position when you want your gearbox, so this will not bind this, because you see this is binding here, but just because I moved this too far away. You will have to find a position where this spins without binding, and then put everything in the place. The easiest thing will be to just attach one hole, one screw, and then play with the positioning. Okay, so I'm gonna pull this top off so we can put the cover, and we're gonna do the electronics. Okay, for switch, I just had a on switch and on off switch. I just made a hole and pass it through and bolt it down with 2 small screws. For you can put it wherever you want in this ring. That's the point. We're gonna wire it up first at the cover. The wiring is very simple, and for this one you can use all power supply, or I will be using a mic drill battery which is 20 volts. So it's just simple, just wire it up, plus minus to the switch, and that's it. Easy wiring, plus to the switch, and then plus to the battery, and minus to the battery. Already an adapter for my battery. You can find it in tanks.com. So we're gonna wire this up. Also, our cables will pass. Get our cover. This adapter is very easy to attach. You can see this originally attached by like a bolt that it can spin. So we're gonna do the same thing. We're just gonna drill a hole here and put a bolt or screw to here. So let's line it up. There is an indentation here that you can see. So the indentation goes down. Make sure that it's kind of straight. Press it down. Make sure that it has a little bit of space, and we're gonna make a hole. Let's up our body. So the next part is you're gonna get this big piece. You're gonna get your slider. It depends on your printer. You may need to sand a little bit, as I did, because something happened to my printer. It was not printing. Then you're gonna screw down for 4 screws. Now you put your screw in. Look at this. You think it will work? I don't. Yeah, it ain't gonna work. It's too slow. So plan B did not work. This gearbox will not work. It's too slow. So we get rid of it. So we're gonna go with this one. This is the back motor for a Power Wheels. It's 3 to 14, I think, ratio. It's a little bit bigger, but it's much more faster. So we're gonna install this one. I already printed the adapter, and I printed this one. This thing took a little more time and more redesigning than I thought, but that's why we call it prototyping. You prototype it, fix whatever needs to be fixed, then you print the actual product. You can see I tried to cut a hole here, so because I wanted to move the whole gearbox here, so the electric motor will have hang here, so it will clear. But I thought that this will not work since we have a hole already here. I just stuck the motor in, then I designed this part that bolts directly to the base. I had broken other parts, as you can see. This is the other electric gearbox that I had. This is the faster one, the one that goes on the back of a Power Wheels or a toy car. You can find them on Amazon, eBay for sure. They are not expensive. And the other idea that I had, probably, so that's why I'm gonna include all the files. I'm gonna include this one, I'm gonna include this one. Whatever you want to use, you can use. I thought that probably maybe if you can cut a hole, you could probably put a step motor. I think the step motors, like from a 3D printer, has much more torque than this thing or the other small electric engine I was trying to use. But this works, so let me give you a little bit overview. I put the cover, all the electronics are inside. Here I'm using a 4mm shaft screws with a nut underneath and a bearing. I wanted to use 2 bearings, but I think 1 bearing is enough. And here I inserted a threaded insert like this. The reason for that one is because I don't want that the bolt will rub on the plastic, and I want something to rub on the bearing itself. So I made it that it sticks a little bit. There is a gap in between them. So basically the threaded insert sits on top of the bearing. So there is no friction in the plastic because it will melt. Does not matter how much and how strong I'm gonna print it, it will make. It will melt. I had a crack here just because I pressed it too much when I was pressing the bearing. It holds, and we're gonna see for how long. I made a hole here so I can put a screwdriver because I did not think of that. So you will probably have to make a screwdriver. But like I said, you could probably get away with a stepper motor and a stepper motor driver. I think that would be the best. If I had, I would have probably tried. Initially I wanted to do this one with a power supply, but I have this adapter that goes to my battery, for my battery operated drill, and we're gonna be using this one. This is 20 volts, should be fine. Those electric motors, those gearboxes are running 12 volts. For 20 volts, I think we should be safe. I don't feel it that it's overheating or anything. There is a flex a lot in the plastic here, and it probably will crack. Like I said, thing like that is not supposed to be printed from a plastic. That's why you can see them all built from metal, some of them are connected with the air, that with like air pistons. They operate with air, they don't operate with electric motors, because it is pretty, it is not heavy up here. Like I said, this is not even 1 kilo, but you need to find the proper electric gearbox and motor for it to work. For you to be able to do this one, you're gonna have to put your gearbox in the hole, and then you will have to figure it out where the holes go. Like I said, I will not put holes just because every gearbox, whatever you're gonna do here, whatever you're gonna use to move this thing, you're gonna have to change or drill the holes. So I just leaving it blank so you can just drill. Like I would recommend this doing in a much higher top layers, maybe like 5mm top layers, so you have enough for the thread inside whatever you're using to grab, or just run bolts and nuts underneath. That's up to you. We got just a normal switch, nothing to it. I put a lot of grease here, there. I redesigned this arm here just because it was not clearing before it was straight. Figured out that wherever I'm using like an angle or something that I need more strength, I will just add the ribs. I think they call them here, as you can see. That gives it much more strength than without. Everything is the other thing is I glue this piece to the gearbox, to this plastic, the blue to the white. That's it. Like I glue the blue to the white piece, just because I don't want to have any movement. You could put a bolt through and bolt it all together, but I don't think it's necessary. I put already my spray paint. This works really nice, and I figured it out. I mean, it depends where you're gonna set this thing up. If you're gonna set it on a desk or something, the best thing is I mean, it shakes them like that. Don't get me. It shakes them right like that without a problem. You can hear the ball going, but you can hear the ball going more if you put the can on an angle. Let's say that it works better if the spray can is on an angle. You can put different things inside, like different paint cans, or don't necessarily a spray paint can, if you can, whatever you can fit. You have to be careful with this one, because again, this is plastic. This well may break. You can put a little bit grease here. I did not put, I like how it fits. So let me show you how it works. Be using this cheap battery for my cheap drill. It says it's 3 ampere if I'm not mistaken, but I don't think so it is. It's 20 volts, but I think this produces a little bit more, 20 plus. You can find this adapter on my tanks.com page. You can find it there. This isn't bolted yet, you're gonna bolt it, but I just want to show you that it works. As you can see, I don't know if you can hear it in the video, because this makes a little bit noise, but you can hear the ball moving inside. I'm gonna attach the base to my table that I have on the back, and we're gonna let it run for a moment. This probably will not last much. There's a lot of flex in the plastic, but like I said, it is plastic. This is never supposed to be meant, you know, to be in that kind of scale, to be made out of plastic. It should never be done. You know, there's a reason why they make them from metal and not from a plastic. Especially this is PLA. This isn't something like nylon or carbon fiber, ABS, whatever that is a little more, you know, more tough. This is just a regular PLA that I had, and I don't even know if my settings sometimes are right when I'm printing them. You know, maybe they even took some kind of humidity and it will go in pieces. I said to myself that if this doesn't work, I'm gonna put another battery on, wire one more 20 volts, give it 40 volts to this engine. For sure we're gonna blow the engine and shake this thing to pieces. But it works, so there's no need. And you know, it took a little bit time to build, and it took a little bit filament to make it speedy to just get rid of a 2 kilo print. There she is in all her glory. Sorry for my tools, but this is the area that this will live in. I just use regular wood screw to attach it, and that's it. So let's see if it still works. As you can see, it works. I should have done something for here, but like I said, someone may use a power supply, so there's no need for a battery. It works. How long it will last, I cannot tell you. Maybe it will last after the first, 10 shakes, or it may last another 100. No one knows. It's plastic, so, probably if it will not break the arm there, probably it will break this one. The base, I don't think so anything will happen to the base. The base is very sturdy. I don't think so. Or here, I don't think so up here anything will happen. If it will break, it will be here or here. One of those two. Or the arm. That thing there. It works. I don't see any issues for a moment. You can see in the video that it has a big flex. Not much on this part, but it has the whole gearbox. And it's not that, because that gearbox had already a flex when it was on the toy car. So I don't know if it's the gearbox or something else. It can have a flex as long as it will not shake itself to pieces. It's not easy to put it together, so you will need to have a little bit of knowledge what you're doing to put it together. As long as you have the parts, you could always adjust it. I don't recommend drilling it or anything, because it will melt. It depends if you go printing it from PLA like me. If you try to adjust to put bigger bearings or something, it will probably melt. Doing it 100% infill, I don't think it's a good idea, because it will be very heavy. So you can save a little bit filament on printing this one into a little bit normal settings, but up here like this one, I would recommend 100% infill. The bar, I would recommend 100% infill. The gear, I would recommend 100% infill. The rest, not so much. I don't know what else to say. Like I said, I wanted to try and to print something like that. I like how it looks. It does not look terrible. It looks like, well, like most of those things that you will find probably online. A good idea probably would be to find something on eBay or Amazon, like a air operated actuators, I think they call them, you know, the thing that goes back and forth like a piston. This probably would be a good idea to print it for something like a, I don't know, a little bit tougher. They are tougher PLA than this one. I'm just using just a regular cheap PLA. They are tougher, that will they are heat resistant, shock resistant, whatever, or printed from a nylon or something like that. I believe if you print it into the right material, right settings, and you put it together right, with the right gearbox, right everything, I believe this probably will work for a good amount of time. I will probably use it wherever I will remember it. I just wanted to make it. That was my goal, to make it, to prove to myself I can make something like that. And it works. I'm gonna make it available for free for everyone to download it. You can modify it. The only thing probably you will need to modify will be this piece here, to add your own gearbox, your own electric motor, whatever you want. This part here, this part, this, all the top, I don't think so that you need to modify it. It all fits nicely, but that's up to you. This was a big print and a big project. It's still, like I said, it's a prototype. It's not a final product. I will probably never print a final product just because this works. But for someone that wants to do the same thing with me, just print it and go from there. Find all the parts. There's no specific parts for it. You will have to make your own. You'll have to buy and, you know, fit your own. So okay, so we are done with this project. We're gonna move forward, go and print and do something else, experiment and something else. And the other thing is, those things usually, those are my experiments. I do like to experiment. I do like to see how far can I push myself, or how far can I push a thing. Like with a 3D printer, how far can I go? What can I make? I believe that with a 3D printer you can make a lot of things. So if you want to download it, I will make the files all available for free. All the links will be down in the description. Subscribe, like and share, and I hope I will see you in the next one.